right, so this is, okay, EPA recently announced a tax of $10 for ozone emissions by power plants. Tax revenue will be used to pay for the medical costs associated with ozone pollution. Lobbyists for the power industry have complained that the tax will be borne completely by the producers of energy and not the consumers. They further complain that because demand for energy is very inelastic, that the tax will reduce pollution by very little and consequently raise little tax revenue. You are paid by a U.S. congressional representative to evaluate that claim by the power industry, and you conclude that the lobbyist they're going to be either right about something, wrong about something else. But they make three claims here. Okay? So what we have pollution. The government wants to tax power plants, right, that produce that pollution, because that's a negative externality. Okay? So to fix it, they want to tax them. Lobbyists, though, for the power plants are saying the following. When they put the tax on the producers of energy, it will be borne completely by the producers. No, that's not true. So there's three claims. Claim number one is tax borne by producers only. Okay? And we know that that's false. Okay? It's always going to be the case that they're going to share in the tax. Okay? Doesn't matter whether it's on producers or suppliers. Oh, sorry, suppliers or buyers. Second claim they make. They complain that because demand for energy is very inelastic, okay, so demand is inelastic, then the tax will reduce pollution by very little. Okay, so they're saying that tax will reduce pollution very little. Okay, is that true or false? It is true, but let's see why. So basically, let's draw a picture again. Supply, demand. If you impose a tax, there's always going to be a reduction in quantity, right? The reduction in quantity produced. In this case, to reduce pollution, we need to reduce the quantity of energy produced as much as possible, right? Because when you produce energy, that's when you pollute. However, it's saying that the demand is inelastic. It means it's steeper, right? That's what it is. So let's draw a steep demand curve. Okay. So if you impose a tax, the tax is going to be the difference between the two curves. So let's impose a tax that's this big. Okay? It doesn't matter what it is, just so we can compare. So it's this big, and if you impose it in the market where demand is very elastic, it's actually here. Okay, so basically those are the same amount of tax imposed in two different markets. One when demand is very inelastic, and one when demand is more elastic. So what happened with the quantity in the two cases? This is the quantity produced in one case, and this is the quantity produced in the other case. So this is with elastic demand, and this is with inelastic demand. And here is the original one, without any tax. So basically what happened with elastic demand, quantity is reduced by a lot. With inelastic demand, quantity is reduced by just a little bit. So they are right in their statement that the tax will not reduce pollution by a lot, right? Because they're still going to produce a lot of energy, so they're still going to pollute quite a bit. So this is true. And their last statement, okay, because pollution will not be reduced by a lot, so basically because the quantity produced of energy is still going to be quite substantial, little tax revenue would be raised. So tax revenue less, well, not a lot. Okay, is that true or not? No, that's false. Let's see why. Well, tax revenue is, right, tax revenue is tax times quantity produced. Right? Tax revenue is the amount of the tax times quantity produced. Well, the amount of the tax is, we know what it is, it's $10. It's always going to be there. That's this part. Right? And tax revenue is actually higher when demand is inelastic, right? Because this amount is higher than that amount, basically. So tax revenue is going to be, yeah, it's going to be pretty substantial. So this is not true. I'll find the answer that, matches those statements. Correct about the tax, yeah, and the reduction in pollution. No, correct about the tax and the reduction in pollution, that's not true. But they're basically not correct about any two things. They're only correct about one of them. So that's not it. They're wrong about both the burden of the tax, yeah, and the reduction in air pollution. No, they're actually right about the reduction in air pollution. Okay, so that's not it either. They're correct about both the burden of the tax, but that's not true, right there. Okay, so they're wrong about the burden of the tax. Therefore, the last one, which is they're correct about the reduction in pollution, yeah, but they're wrong about the tax revenue. That's the one. Okay? So this is D in this case. Okay. Okay, so we have a figure that has three different supply curves. Which of the following would cause the supply curve to shift from A to C in the market for tennis rackets? Okay, so we're going from A to C. A shift to the right means increase in supply. Okay, so we need something to cause an increase in supply. This is the tennis rackets market. Okay, what would cause? Okay, so which one of those would cause an increase in supply? An increase in the price of tennis balls. Okay, so tennis balls are more expensive now. Are those two goods, tennis rackets and tennis balls, complements or substitutes? Complements, obviously, right? So if tennis balls are more expensive now, what is this going to do to the market for tennis rackets? Is it going to shift demand or supply? Demand. So it will not cause any shifts in supply. So that's not it. An expectation by firms that the price of tennis rackets will increase in the very near future. Is that it? So if you're a supplier and expect the price to go up in the future, are you going to supply more or less today? Less today, true? So that's not it. That actually causes a decrease in supply. A decrease in the price of tennis racket strings. Yeah, that seems to be the one, right? The strings, they are input, right? They're resource in the production of this good. So if the price of the resource goes down, then it's cheaper now to produce, so we're gonna supply more. That must be the one. Let's see the last one. A decrease in the number of firms selling tennis rackets. What would that cause? There's less sellers. It's a decrease in supply. Okay. Right. This one's C. All right. Buyers of a product will bear the larger part of the tax burden, and sellers will bear the smaller part. When? Which of the following is true? All right. So when the tax is placed on the sellers of the product, is that true? Does the burden depend on whether sellers or buyers are taxed? No. So those two are not true. Therefore, it must be one of the other two, right? And this is about supply of the product is more elastic or less elastic than the demand curve, and that's what's gonna. Well, you can, if you know the definition, you'll be able to answer. But let's look at a picture again and see why that is the case. So let's say we have this market, supply and demand. Well, we said that the burden to buyers, okay, let's look at buyers, is always going to be this distance divided by the whole. Right? It's always going to be the case. So they're pretty much equal in terms of slopes here, right? So there's kind of, in terms of relative elasticities. So let's change the elasticity of one and see what happens. Let's change the elasticity of the supply curve, for example. I'm going to make it more elastic, so flatter. It will again pass through this point, but now it's going to be more elastic supply. What happened to the burden for buyers? Well, it's still this. Okay, so that part is the same, but now it's divided by something smaller. Okay, so what does this tell me? When supply is more elastic than demand, okay, so when elasticity of supply is higher than the elasticity of demand, well, what happens? Buyers are going to bear more of the burden. Right? Or you can think of it this way, suppliers bear less. Because before suppliers were this divided by the whole thing. Now they're this divided by the whole thing, which is definitely less. Okay? So basically when that's the case, buyers bear more relative to suppliers. Okay, you can remember this as a rule. It's always going to be the case. Or if you forget about it, just draw the picture and you figure it out. So when the supply of the product is more elastic than the demand of the product, yeah, that's the one. So the question is, when will buyers bear more of the tax burden? And that's when the supply is more elastic than the demand. Okay? Let's see. All right. All right, so here we have budget constraint. Okay, there's a good y. This is actually the quantity of good y, and then the quantity of good x. There's a certain budget or income that a person has, and this tells us, the budget constraint tells us what bundles they can consume if they spend all their money on those two goods. Right? What do the intercepts tell us? So the y-intercept here, that will tell me,
they only bought that.
Right, so if they spend all their money on good y, how many units can they buy? And this one tells me if they spend all their money on good x, how many units can they buy? Okay, let's be straight. All right, so if the consumer has $600 in income, what is the price of good x? 6, right? So I know that this point here tells me if they spend all their money on x, how many can they buy? Well, if they spend their $600 on x, they can buy 100 units. So that means that the price of x is $6. Okay? So the price of x would be the budget divided by the x-intercept. Pretty much. Right? No. That doesn't make much sense. Let me put it this x-intercept. And then the price of y would be the budget divided by the y-intercept. Okay. What is the slope of this curve? Not in this case. Theoretically, what is the slope? Okay, so what do we have? We know that if we spend all our money, then our budget would be comprised of the price of y times the quantity of y that we bought, right? Plus the price of x times the quantity of x that we bought. Now, any line has the following form: y equals b plus mx, right? This is the good, or the variable on the y-axis is always going to be intercept plus slope times the variable on the x-axis. What do we have here? Our y is actually quantity of y, right? So this is our y, and our x is the quantity of x. So if I rearrange that equation and express it in terms of quantity of y, it will have this form. Let's see what that is. So I'm solving for the quantity of y. Therefore, I have the price of y times the quantity of y equals my budget minus the price of x times the quantity of x. I want quantity of y by itself. I'm going to divide both sides by the price of y. So quantity y equals the budget divided by the price of y minus the price of x over the price of y times the quantity of x. Okay, so this is a line, therefore intercept, slope. Do you see it? So the slope of the budget line is always going to be the relative price, price of x over price of y. Okay. And the intercept, we see it's just the budget divided by the price. All right. I think that's for one of the next questions. Okay. This one, actually. All right, suppose the only two goods are wine and cheese. When wine sells for 10, a bottle, and cheese sells for 10, the person buys 6 bottles of wine and 4 pounds of cheese, spending his entire income of $100. One day, the price of wine falls to 5, and the price of cheese goes up to 20, while the income does not change. If you illustrate wine on the vertical axis and cheese on the x-axis, then what is going to happen to the slope of the budget constraint? Okay. All right, so they tell us to illustrate wine on the vertical axis. So here we have quantity wine, and here we have quantity cheese. Well, what is the slope of the budget line before the price changed? We just calculated it, so what is it? 1, right? It's the relative price, which is the price of x divided by the price of y. It's always negative, right? Because the budget constraint is negative. So before the price change, initially, the price of x was 10 and the price of y was 10. Now the price of x, which is on the which is cheese, has gone up to $20, right? So the numerator has increased, and the price of wine, which is on the y-axis, has gone down to 5. Okay. All right, so the numerator has increased, the denominator has decreased. Both of those increase the ratio. Right? So initially the slope was 1, well, -1. After the change, the slope is, what's price of x? 20. That's an x here. Divided by 5, so it's now negative 4. Right? So that's steeper. If you don't want to do this way, you can just draw them. Okay. We have $100 to spend. Initially, the prices are 10 and 10. So if I spend all my money on wine, how many bottles can I get? 10. Let's make it here. If I spend all my money on cheese, 10. This is my initial budget constraint with a slope of 1. Right? Now, price has changed. Y now costs $5. So if I spend all my $100 on wine, how many bottles can I get? 20. Okay, twice as many here. Cheese is now 20 bucks. So if I spend all my $100 on cheese, 5. All right? It's steeper because its slope is now -4 compared to -1 before. Therefore, well, which is it? C. Okay, so the first one is not true because the slope has changed. So when there's a change in the price, right, the slope is generally going to change unless the change in price is such that they offset each other. But in this case, we didn't have that. The slope of Lorenzo's budget constraint is steeper, that's true. Lorenzo's budget constraint has shifted in a parallel fashion to the budget constraint with the old prices. What will cause a shift in the budget constraint in a parallel fashion? More money. Okay? Either when income goes up, the whole budget line going out here, right? Because now we can buy basically more of each. But because the prices don't change, the slope doesn't change. And if income goes down, right, we have a parallel shift again, but to the left, because now we cannot buy as much of both. Questions? Okay. Okay. So here we have a bunch of budget lines and in different curves. So what we're told, the price of X is $6, the price of Y is 24, and income is 48. Okay, so the price of X is 6, the price of Y is 24, and income or budget is 48. Okay, so let's figure out which budget constraint are we on here. So this is X. If I spend all my money on X, how many units can I get? On X? 8. So this is my X intercept. If I spend all my money on Y, how many can I get? 2, which is here. Right? So I'm initially on this budget line here. Agreed? Well, based on the indifference curves, the optimal point for me is C. Okay, so I'm going to consume 4 X's and 1 Y. That's optimal for me. Okay, Paul's optimal choice is C. All right, good. And then the price of Y decreases to 8. What is the new optimal choice? Okay, so the price of X hasn't changed. Okay, I'm still here at 8. Because if I spend all my money. So neither the income nor the price of X changed. The only thing that changed is the price of Y, which went down to $8. So if I spend all my money on Y, with the new price, how many can I get? 6. So now I'm still at this point for the X-intercept, but now I'm here in terms of Y-intercept. Okay? And what's my, on this budget line, what's my optimal point consumption? D. Right, so this is basically figure out which budget constraint, which line you're on, and then what's the optimal point in that, on that line. And that will be D, which is answer C. Okay. Okay, we're still in this scenario. Okay, when the price of X is 40, the price of Y is 40, and income is 160, optimal choice is B. Okay, so if price of X is 40, how many can I buy if I spend all my money on it? And Y? 4. So I'm on the 4-4 budget constraint, which is here. And then the consumption point is B, optimally. Right? So they're buying 2 of each. Then the income increases to 320. Okay? So what did we say before? When income goes up, what does that do to the budget constraint? A shift to the right. Okay? Now the slope is going to be the same because the relative price is the same. We're still the slope is still going to be 1. But now we can buy more of both goods. And that's what they do. So with 320, how many of each can they buy? 8. So now we are on the 8 curve, which is here. With optimal point E. Agreed? Okay, now we established what happened. The question is whether the goods are normal or inferior. Okay, so what's the definition of a normal good? Yeah?
As wages increase, your consumption.
Right, as income goes up, your quantity demanded of that good is going to go up. Right? That's a normal good. An inferior good, when you have more money, you actually spend less. You spend less on it, so you buy less of it. Bus tickets. When you have more money, you can buy a car and no longer ride a bus, for example. Okay. So what happened with the, well, income increases. So now we need to see how the consumption of those 2 goods changed. The person, Paul, moved from point B to point E. Well, so let's see for the Y good. Originally he bought 2, now he's buying 4. Right? Is this a normal good? Yes. Okay. And for the X good, originally he bought 2, now he's buying 4. Again, a normal good. And that's answer C, where both of them are normal goods. Okay, your neighbor owns an apple tree, and some of the apples drop in your yard. You don't like to eat apples, and the fallen apples make your yard more difficult to mow and ruin your grass. Okay, so we have a conflict. Your neighbor values the apple tree at $1,000, but your costs associated with the apple tree are $2,500. Suppose your neighbor has the legal right to keep the tree under any circumstances. Okay, so what's going on? There's a tree, and one person is getting a value out of that tree, which is $1,000, but another person is getting a cost from that tree, which is $2,500. Okay, so the net social kind of value of this tree, is it positive or negative? Right. Net, it will be negative 1,500. So under Coase's theorem, if they're allowed to negotiate, the 2 parties, what's going to happen to that tree? What does Coase tell us? If there's no cost to negotiation, and you let the 2 parties agree on something, what are they going to agree on? What is socially optimal? Right? So in this case, the tree should go. right? Because it's socially optimal for the tree to go. Okay. Now, how is this going to happen? Well, the important thing here is that your neighbor has the right to keep the tree. Okay? So you need to kind of incentivize your neighbor to cut the tree down. The question is whether they'll be willing to, or will you be willing to pay them enough to do so? Right, so the first answer is you call the Department of Public Works to have the tree cut down. Can you do that? That's not illegal, right? Your neighbor has the legal right here, so you cannot do that. You pay your neighbor $2,000 to cut the tree. Right? Are you willing to pay your neighbor $2,000? Yeah, because to you, it costs $2,500. So you're better off paying $2,000 instead of $2,500. So you are willing to pay that money. Then the other question is your neighbor willing to cut it down if you paid him that money? And that answer is also yes. Right? Because for them, they only value the tree at $1,000, but now you give them $2,000, so they'll be happy to cut it down for you. Right? And then both parties are better off and the tree is gone, which we know is the optimal outcome. So that's B. The other two are your neighbor pays you something to not have the tree. They don't need to pay you anything because they have the right to not cut down the tree. Sure. Okay. So the answer here is B. 23 is the same scenario, and the question is, what is the socially optimal outcome in this situation? So we already discussed that. So what is it? Any agreement which does not involve legal fees. That's weird, no? Your neighbor keeps the tree because he's legally entitled to keep it. No. Your neighbor keeps the tree because cleans up the mess it makes in your yard. They're under no obligation to do so, right? So the socially optimal, as we said, is your neighbor cuts down the tree. Okay? This is answer D. Okay, so so this is about pollution reduction. We have 3 firms, A, B, and C, and each of them pollute, right? Whatever production they have, they emit pollution. And they have different costs of eliminating pollution. What this tells us is, so for firm A to eliminate 1 unit of pollution, it costs them $50. Right? But then the next one costs them $65, and the third one costs them $70. Right? That's what those numbers mean. They're the marginal cost of eliminating each additional unit of pollution. Right. Then the government sells a fixed amount of pollution permits at $69 each. And each permit entitles the holder to emit 1 unit of pollution. So in other words, if I hold 1 permit, any of these firms, then I need to eliminate 2 units of pollution, right? Because I'm only allowed 1. If I hold 2 permits, then I need to eliminate only 1. If I hold 3 permits, then I don't need to eliminate anything. Right? The permit gives me the right to pollute. Does that make sense? All right, if that's the case, how many permits will be purchased by the firms? Now let's look at each individual firm. The permits cost $69 each. So starting from the bottom up, is the first firm going to buy at least 1 permit? Yeah, right? Because they would rather have the permit than eliminate this third unit of pollution for $70, because the permit is cheaper, it's $69. So they'll have at least 1. Okay. Are they going to have 2? Well, if they buy another permit, they're going to have to spend $69 on it. but they can instead eliminate that unit of pollution for 65. So they're not going to buy another one. Okay? To the next firm. Are they going to buy at least one? Yeah, because for them, the third unit of pollution would be too expensive, so they would rather get the permit and just pollute here. They're going to buy at least one. Are they going to buy two? No, right? Because to buy the additional permit, they need to spend 69, and they would rather just pollute. No, sorry, just eliminate pollution instead at 65. And finally, the third firm, how many are they going to buy? Two. Okay, so they're going to buy two and just eliminate 1 unit. In total, how many permits will be purchased? Well, 4. Okay? All right. So we have production possibility frontiers for 2 countries, Chile and Colombia. We can produce soybeans or coffee. Chile should specialize in the production of what, is the question. All right, so whenever you have a problem like this, what I suggest is for each country individually, looking at the trade-off between the production of the 2 goods. So what the production possibilities frontier tells us is if they allocate all of their resources to the production of these goods, how many units can they produce? This is like the budget line, right? But for countries and in production. So if I spend all my resources in the production of coffee and none in the production of soybeans, I can produce 16 units of whatever the unit is of coffee, right? And if I spend all my resources on soybeans, then I can produce 12. Right? And any combination between the 2 of them is achievable for me with my resources. Right. So the question here is, what is the opportunity cost of producing one good in terms of the other? Okay? So the more resources I allocate to the production of soybeans, the less resources I would have for coffee. So what is the relative cost in this country of soybeans and between soybeans and coffee? Okay, so to set it up, I do an equivalence, kind of an equation, which tells me that if I spend all my resources, I can either produce 12 soybeans or 16 coffee. Okay? Then I'm going to express each of those goods in terms of the other good. That gives me the opportunity cost of that good. To express it in terms of the opportunity cost of soy, I'll divide both sides by 12. Right? So I'll get 1 soybean, or 1 pound of soybean, is equivalent to 16 over 12, which is what? 4/3, 4 over 3 coffee. Okay. So to express coffee in terms of soybean, it will just be the reciprocal of that. Okay. So instead, I will divide both sides by 16 instead of 12. And then I'll have 1 coffee equals 12 over 16, or 3 over 4 soybean. Okay. So this is the opportunity cost of soy, and this is the opportunity cost of coffee. They're always going to be reciprocal of each other, right? And this is happening in Chile. Now I want to see the exact same thing for Colombia, and then I'm going to compare between the 2 countries and see where the opportunity cost of one of the goods is cheaper, right? And then that country should specialize in the production of that good. That would necessarily mean that it's cheaper to produce the other good in the other country, right? So definitely the other country should specialize in the other good. So do the same for Colombia. What's the trade-off there? The trade-off is between 6 soy and 12 coffee. So the opportunity cost of soy, it's 1 soy for 2 coffees. And the opportunity cost of coffee is the reciprocal of that. So 1 coffee is 1/2 soy. Right. Now I'm going to compare across countries. What is the opportunity cost of soy here? It's 4/3. And here, so that's 1.1 something. And here it's 2. So where is it cheaper to produce soy? In Chile. And you're done. That's it. Okay? So it's cheaper to produce. So Chile should specialize in the production of soy. Necessarily that means that Colombia, the other country, should specialize in the production of coffee. And to see why, because it's cheaper there. Right? It's only 0.5. And here it's 0.75. Okay? Now, if Chile only produces soy and Colombia only produces coffee and they trade with each other, then both countries would be better off. That's the conclusion. With free trade, that's going to happen for sure. Chile should specialize in the production of, what did we say? Soybeans and import coffee. So C. Okay. Okay, country A is a well-developed large country. If it devotes all of its resources to steel, it can produce 10 million tons of steel. If it devotes all of resources to corn, it can produce 100 million bushels. Country B is small, developing country. All of its resources to steel can produce 250 tons, right? So substantially less, obviously, of steel and 5,000 bushels of corn. The production possibility frontiers for both countries are linear, so like we had in the other case, in the previous problem. Which of the following statements is correct? Okay. Is it true that country A cannot benefit from trade with country B because B is too underdeveloped? No. Right? That's not true. It would always be the case that whoever has the comparative advantage in the good should produce that good. And then when they trade, both countries would be better off. Right? Doesn't matter whether one's small, the other one's large. With trade, they will be both better off. So this is not true. Country A cannot benefit because they have the same opportunity cost of steel production. Well, that we'll have to see. Right? That might be the case, but might not be the case. Okay, and then both countries can benefit. Wait, that cannot. No, it could. Okay, so now we need to see which country has a comparative advantage in what and what they should produce. And again, as before, set up the trade-off. So for country A, the trade-off is 10 million steel. Okay. So 10 million steel or 100 million corn. Okay, so 1 steel, or the opportunity cost of steel in country A, is 10 corns, or bushels of corn, right? Do the same for country B. There we have, what's the trade-off? 250 steel is equivalent to 5,000 corn. Okay, so 1 steel, the opportunity cost of steel in that country is 20 corn. Right, so which one should produce steel? Country A or country B? A. And that's it. That means that country B should produce corn, and they trade with each other, and both of them benefit. Okay. Which one is that? Both countries can benefit if A specializes in steel production and B in corn. That's the one. Right? That's C. Okay, suppose supply is this equation and demand is with this equation. If there's a 5 per unit positive externality associated with this market, what is the socially optimal quantity of output? All right. So before we had an example with negative externality, now we have a positive one. Supply, demand. So we know that when there's no government intervention, this is not optimal. Okay, but what would be the socially optimal outcome? In this case, we have a positive externality. All right. So what does that mean? Is the supply curve or the demand curve the wrong one? Demand, because here we have a benefit that's not realized. Before we had a cost that was not reflected, and cost is supply. Here we have a benefit that's not reflected. So basically each buyer, right, they're willing to pay a certain amount, but their value, the value that they get from consuming that product is actually higher than they realize. Okay? Higher than represented by the demand curve. So when you have a positive externality, that's a shift of demand to the right. Okay, demand's higher actually. The socially optimal demand is higher. And it's higher by exactly the amount of the externality, by 5 units. So, let me do this. So whatever the intercept was here, right, the demand intercept, this new intercept is 5 units higher. Okay. The slope is the same, so they intersect somewhere. And that's my quantity that's socially optimal. And that was my quantity initially. So you see, when there's an unrealized benefit, we're actually under-consuming that good. Right? We're consuming less than we should be. And when there was a negative externality, because there was an unrealized cost, we were consuming more than we should have. Or what's socially optimal. Okay, does that make sense? So the question is here, what is optimal quantity of output? Well, when we had this question before in the previous exam, so if you have certain supply and certain demand, how do you find the quantity, the optimal quantity? You set them equal to each other, all right? But if I set those two curves equal to each other, I would find this, and that's not what I'm after, right? I'm after the socially optimal one. So what do I need to change in order to get the socially optimal one? Add 5 to the demand intercept, and that's that. And then set them equal to each other, so for quantity, and I will have the optimal quantity. Right, so supply is 3 plus 2Q, and I can name this the socially optimal Q. And demand is now, it has an intercept of 33, but the benefit is 5, so its intercept is going to be actually 38 minus 3 times the socially optimal quantity. Okay, so rearrange and solve. What is it? 5 times Q equals 35. Socially optimal quantity is 7 units. Right? That is A. So what will be the equilibrium quantity without any government intervention? It will be less than that. Right? It will be less than 7. It's actually 6. So basically this is 33 instead of 38. Right? And when you solve, it turns out to be 6. So this is, the one that we are after is 7 here. The one without intervention would be 6. Okay. How does the government intervene? Subsidy. Right? When there was a negative externality, there was a tax that solved the problem. And when there's a positive externality, then you provide a subsidy. The subsidy shifts the demand curve. Right. That is A. Okay. Alec is a lawyer who was earning 200K at a major law firm. He decided to open his own firm by cashing in a 100K bond that was earning 10%. He also borrows 100,000 from the bank at 10%. He hires a paralegal at 100,000 per year, and his rent is also 100,000 per year. Question is, how much revenue does he need to earn in order to make zero economic profit? Okay, what's the key word here? Economic, as opposed to accounting. All right, so we're going to have both. We need to account for both the accounting costs and the opportunity costs. All right. So what is an accounting cost? From those that are listed here, what is the first one?
Salary, employee.
Sorry?
The salary of an employee will be one.
The salary of the employee. That's right, the paralegal here, right?
Well, then the rent.
The rent too, right? So the salary, the rent. So this one and this one. Anything else? That is an accounting cost. Interest on the new loan, right? So plus 10% times 100,000, which is 10,000. So the accounting costs, anything else? In terms of accounting costs, that's that. In total, they are 210, right? 210,000. Okay. What are the opportunity costs? What's an opportunity cost?
200,000.
Right, his salary before, right? Because he started his own business, that means he needs to quit. If he hadn't quit the job, then he would have still gotten the 200,000. So now that's an opportunity cost to his new business. Anything else?
The interest on the bond that was earned.
Right. So because he started the new business, he needed the amount of the $100,000 that was previously earning 10%. That's an opportunity cost now, right? Because if he hadn't started a new business, then that bond would have still earned that 10%. So another 10,000 here. Okay, so opportunity costs are 210, accounting cost, therefore the economic cost is 420. Okay, to make zero economic profit, profit is total revenue minus total cost. Well, if the cost is 420, to make zero profit, he needs to make at least 420 in the revenue. Okay? That is answer D. Okay, so we have a cost of long run. Okay, we have a table of long run total costs for, well, it says 4, but it's actually 3 different firms, right? There's 3 firms, and then I have, based on the quantity produced, what the total cost of production would be. Which firm has economies of scale over the entire range of output? What is the definition of economies of scale? When do we say we have economies of scale? What needs to happen as quantity increases to call it the economies of scale? Well, it obviously has to do with long run costs, right? The picture looks something like that. And we called this region from here to there, the region where they're experiencing economies of scale. And this region was the opposite of economies of scale. these economies of scale. You guys should, anyway. All right, so what is this curve that I'm showing here? A curve of what? Is it total cost? Or is it something else?
Cost per unit.
Sorry?
Cost per unit.
Which is also called?
Margin.
Average. Average total cost. So this is the average total cost curve. So as quantity increases, what needs to happen for us to have economies of scale? Average total cost. As quantity increases, this is quantity, right? This is cost. As quantity increases, what happens with average total cost? Decreases. Okay? So the definition of economies of scale is that as quantity goes up, average total cost needs to be going down. Now the question becomes, which of those firms has that? Looking at it, can you say which of them? Just looking at the table. What do we need to do? Do we need to fix the table and do something else with the table, or can we just look at it and decide? No ideas? Yeah?
Find out the average total cost of each firm.
Sorry?
Find out the average total cost of each firm.
Right, exactly. We need to find out what the average total cost of each firm is at each quantity. This here is my total cost, okay? And it is increasing for all of them, which is normal. But the average total cost might be staying the same, increasing or decreasing. I need to figure out for which firm is it decreasing throughout its, for all of the quantities. So basically, for each firm, I need to calculate this total cost divided by the quantity. All right, so what's easy to do? 2. Okay, so 2. Let's start here. 11 divided by 1 is 11. 24 divided by 2 is 12. And I can stop here and tell you that 2 is not one of them. Right? So firm 2 doesn't have economies of scale because its average total cost is not decreasing over the full range of quantities. I mean, it's not decreasing in the first one, so it's automatically out. If 2 is out, this one's out and this one's out. Okay, now I have 2 choices. Let's do 3. 3 seems easier. So this is 21. This is 17. Right? No, is that how it was? Yeah, I guess so. What is this? Something, right? 18 point something. So this one's out too. Right? Because it was decreasing here, but then it starts increasing. So it's out. And we're pretty much done. Only one. And if you want to check, you just divide. Right? So this is 60. This is 35. What is this? 23 something. No, it's 27 something. And so on and so forth. You see that it's decreasing for all of them. All right? This is A, should be A. Okay, suppose the total cost facing a firm is represented by the equation. So total cost is 250 plus, that's 2 there, that's 2 times Q. All right, so this is my equation for the total cost. I can find for any quantity of production, what's my total cost? That's what this tells me. First question is, what is the total cost of producing when the firm produces 50 units of output? And just plug that in and see what it is. All right. So total cost is 250 plus 2 times 50? Yeah. Plus 2 times 50, or 250 plus 100, $350. And that's that. That is B. Wait, C. 350, C. Same total cost, same problem. Question is, what is the marginal cost of producing the 100th unit of output? Well, first of all, by definition, what is marginal cost? The additional cost, right? So the extra cost that you're going to incur because of that, in this case, 100th unit. In terms of mathematically, what is the marginal cost?
Changing price by changing production.
Not changing cost.
Yeah.
Right? So mathematically, the marginal cost is the change in the cost for that particular unit. Or if you want to use calculus, it's actually the first derivative of the total cost curve. Right? So let's do both. Well, first of all, when you have, all right, so what's the first derivative of this equation in terms of Q? So total cost with respect, first derivative of total cost with respect to Q is what we call the marginal cost. And it is, in this case, 2. Right? So whenever we have linear total cost, then we have then the marginal cost is constant. Right? It's the same for each unit. Doesn't matter whether you're asked about the 100th unit or the 90th unit or the 5th unit. It's always, the marginal cost is always going to be the same when you have linear total cost. And it's just 2 in this case. To see why that is, we can do it the algebraic way. So what's the total cost at 100 minus the total cost at 99? That's what the marginal cost of the 100th unit is. Right? The marginal cost of the 100 is the difference between my total cost with 100 units and total cost with 99. Okay, so my marginal cost would be 250 plus 2 times 100, right? Minus 250 minus 2 times 99. Right? If you plug it in, that's what you get. This cancels. I can factor out the 2, and then I get 100 minus 99, right? Which is just 2. Correct? And then notice that whatever number I want to find the marginal cost of, it's always going to be that case, right? If I want to see 50 versus 49, it's always going to be just 2, right? So the marginal cost of 50th unit is also going to be 2, which is a result of having linear total cost. That's that. So answer 2, A. Same scenario. But now the question is, what are the fixed costs facing this firm? Sorry? 250. Why? The fixed cost, by definition, you're going to pay whether you produce or not. Okay? So basically, the fixed cost is going to be your total cost at quantity 0. Because even if you don't produce anything, you still have to pay the fixed cost. So my total cost when quantity equals 0, well, plug in 0 in the equation and you'll see it's 250 plus 2 times 0. This is 0, so it's just 250, which is my total cost, B. All right, this is pretty straightforward. All right, so I have the cost curves here. Right? You must be very familiar with this picture. We have average total, average variable, and marginal costs. In this question, we are asked what are the fixed costs for this firm. Okay, so we know that total cost is comprised of fixed and variable. Right, that's always going to be the case. It's comprised of fixed costs, well, total fixed costs plus total variable costs. Do I have do I have any of those here? Total variable, total fixed, or total cost? What's the difference between this and that? One is average, the other is total. Right? So to get the average from the total, what do I need to do? Divide by the quantity. Okay? So if I divide by the quantity on both sides of this equation, I'm going to get that the average total cost, right? So divided by Q, divided by Q, divided by Q. The average total cost is equal to the average fixed cost plus the average variable costs. I am after fixed costs. Okay? So if I express the average fixed cost in terms of the other two curves, which I am given, it will be the difference between the average total, right? The average total cost minus average variable cost, that will give me average fixed costs at any quantity. That's always going to be the case. So now that I'm after, I need to find this. I know the average total and the average variable costs. I have the curves here. So what I need to do is just pick any quantity. Any quantity. Well, usually you should pick something that looks easy to figure out what the costs are. For example, here, at this quantity, which is 27.5, I guess. Okay. At this quantity, my average variable cost seems to be about 12.5, right? And my average total cost is 25. Okay, so at quantity equal to 27.5, my average total cost is 25. Right, I figured it out by looking at the curves. And the average variable cost is about 12.5. So at a quantity of 27.5, what is my average fixed cost? Looking at this equation and this data, average fixed cost, the difference between the two, right? So the average fixed cost would be 12.5 at a quantity of 27.5. What's my, well, the question is about the total fixed cost, not the average, right? So how can I go from average to total? Multiply. All right, so the total fixed cost would be the average fixed cost times the quantity, and that's 12.5 times 27.5, which is more than 350. Okay, agreed? Now we can do this because the total fixed cost, it doesn't change, right? It doesn't matter what quantity you are. The fixed cost is always going to be the same. So that's why we can just pick any quantity and figure it out from there. All right. Okay. Total cost. Okay, so now total cost is quadratic. All right. It's not going to be linear this time. The total cost for this firm is 200 plus, and let's distribute the 0.5. So it's 0.5q plus 0.5q squared. right? That's total cost as a function of quantity. Well, you can be asked here, what's the total cost at quantity of 5, let's say, right? You just plug in 5 here and 5 squared, and then you solve. That's it. But what we are asked here is, what is the firm's marginal cost of the 6th unit of output? And the correct answer below assumes you will use the discrete definition instead of calculus. All right. So let's do it with calculus first. We said that the marginal cost at any quantity is the first derivative of the total cost with respect to Q. What's my marginal cost formula here? The first derivative of total cost with respect to Q. Well, this is 0, right, because it's constant. This is 0.5. And this? Right, well, Q. Right, so it's 2 times 0.5 times Q, which is 1. So it's basically 0.5 plus Q. That's my marginal cost as a function of Q. Now, I'm asked what's the marginal cost of the 6th unit of output. I just plug in 6, right, and find that the marginal cost when Q equals 6 is 6.5. Now, the closest one is A, so the answer is A. So now let's solve it with the discrete method, and then we're going to find 6. Where's my?
You don't have to do. I mean, if you do the calculus.
If you do the calculus, you don't have to, right? So the answers are going to be different enough, right? There's nothing closer than the correct answer to the one you get with calculus. But let's do it in the other way too. All right. So we said that the marginal cost of any quantity I can express as the difference in total costs between that quantity and the one before it. There's going to be total cost at 6 minus total cost at 5, right? That's my marginal cost of the 6th unit, like we did with the 100th unit before. Okay, plug in and solve. So I have 200 plus 0.5 times 6 plus 0.5 times 6 squared, which is 36, minus 200 minus 0.5 times 5 minus 0.5 times 25. So the 200 goes. I can factor out the 0.5. So I have 0.5 times, and then I have 6 plus 36 minus 5 minus 25. This is 30, so it's 0.5 times 12, which is 6, which is the marginal cost with no calculus. And that's A again.
Considering the calculus, you know what I mean, doesn't, well, when you're using a derivative, because the 200, it's not going to factor that in, which is why you need 6.5. But they're going to ask a question in which they give you A is 6.5 and B is 6.
No, that's what I said. The answers are going to be...
There won't be a question like that where the two answers are so alike.
No, when the question is going to be... The correct answer is going to be different enough from the other answers, so that whether you do it discretely or with calculus, you're still going to know that that's the right answer. All right, and the final one, this is the final question, again the same cost curve, and this question is, what is the fixed cost facing the firm? That's easy enough. What is it?
200.
It's just 200, right? So we said that the fixed cost is, we can find it by plugging in 0 in the total cost function. So the fixed cost equals total cost at Q equals 0. Well, plug in 0, you get 200 plus 0. So the fixed cost is just 200, which is T. Any questions? No? All right. Good luck on the midterm, guys.